Hi guys, Mr. Gersha here. This is video 1 of the tutorial series on using Microsoft Excel for your IB Labs. Alright, so we're working in 365. So when you open up the document, first thing you have to focus on is editing in the proper workbook. I think it's best to edit in Excel. Not the browser, because when you go in the browser you lose a lot of the functions. So it's going to bring you these windows. You launch application, yes, and hopefully it opens up Excel for you and everything works out. Okay, so we have our Excel open. We have to click here to edit workbook to engage, and we should be good to go. I'm just going to maximize this. Alright, so in this video I'm going to walk you through some of the basics of calculating standard deviation, creating a basic graph, and running a t-test. Okay? And that'll carry over into some of the other assignments. I'm just going to switch here to the practice assignment for this one. Okay, so the first thing we want to do is let's just go through the standard statistical functions, alright, first. So let's set up a cell. We're going to calculate our means. So here I'm just going to type in mean. So we're going to get the average of our two sets of data here for plant 1 and plant 2. So we want to make this cell active. So from here we're going to go up to formulas, more functions, statistical, and we're just looking for the basic average. So when you hit that, if you notice, this cell is assuming that we want to average the numbers from cell B2 through B12. Now you can leave that, that's fine, or you can choose what cells you want to be averaged. And then we hit OK. Alright, now the shortcut here is, if you look right here, that little square, we get the crosshairs over, you click and you drag the cell over, it automatically punches in the average for plant 2, so you don't have to go through that whole process again. Now what you notice here is all these are to the, alright, they're rounded to the nearest whole number. In IB you always want your decimal places to be the same. So the fact that these are, they should have been to the 10th, but for all argument's sake we want to change these to a whole number. So what I'm going to do is I'm going to right click on there, I'm going to go to Format Cells, I'm going to go to make sure my number tab's open, I'm going to click on number, and I'm going to change the decimal places to 0. And bingo. Now they've been rounded to the nearest whole number. So that's our means. Easy enough. Alright, so from there we want to get our standard deviation. So I'm just going to put a little initial for standard deviation. Highlight that cell just below. Alright, because our standard deviation is going to represent how the data is spread around our mean. So again, we go up to more functions, statistical. Now you can do a search at the bottom where it says insert function, or you can just scroll down till we hit, we're going to use this standard deviation, okay? Just based on the entire population, all right? That should be fine for us. So again, here we are. Now we're highlighting just the data set. Do not highlight your mean, just the data set from days 1 to 10, and we say OK, and there's our standard deviation, and we're going to do the same thing here. We're going to click on there, drag it over, and now we have the standard deviation. Now notice here we have all these crazy decimal places. Again, with this you don't want to have too many decimal places, so being everything is a whole number, we're going to right click, Format Cells, Number, 0 decimal places, And there we go. There's our standard deviations. All right. Now let's run our t-test, being that we're sticking with the statistical functions. Okay. So what our t-test is telling us we're comparing the means of the two sets of data to see if there's any kind of statistical relevance and how closely related they are, so to say. So here we go up to more functions, statistical, and again, scrolling down. And we're going to go to t-test. Now at the t-test you see here we have array 1 and array 2. That represents our two populations. Okay? So remember, in bio we're looking at that p-value of 5%. If your p-value is greater than 5%, that means you accept the null hypothesis, which states that there is no significant difference between the two sets of data. If your p-value is less than 5%, that means we accept the alternative hypothesis, which states that there is a significant difference between the two sets of data. So here's how we're going to run our t-test. I'm just going to move this down so I can read. All right, so we highlight array 1. Again, we're just highlighting the data, not our means and standard deviations. Oop, we got to do that again. So we highlight array 1, click in array 2, highlight array 2. Now tails, okay, we'll discuss this in more detail when you're doing your lab. We're just going to run a one-tail test, and the type is going to be a type 2, which is unpaired, which means we're comparing two separate populations. It's not a before and after. It's not the same group being tested a second time. We're just comparing two separate populations here, so that's why we're running a two-tailed t-test. And here we click, and you can see the number we get. Now at your t-test, it's okay to leave this to the number of decimal places that you see. All right? Because based on our t-test, we see that this number is less than 0.05, 5%. So this means that we would be accepting the alternative hypothesis, which is basically saying there is, statistically speaking, a significant difference between these two sets of data. Okay? So that handles our statistical functions. So now let's make the graph. All right? So we're going to insert a graph. So here it says graph both lines on the same graph. We're going to create a line graph. All right? And then we're going to make a separate graph that has to do with just calculating the means, including error bars. All right. So here we're going to insert. Now we can do a shortcut for our line graph. All right. If we highlight both sets of data, this is the new shortcut way. And I go to insert, and we're doing a line graph, and we're just doing a standard line graph. We have our graph. All right. Now this is a new little function over here. We don't need a chart title because you're going to put a descriptor in, as we discussed in class. All right, but we have our series here: growth of plant 1, growth of plant 2. The only thing we need to add to this is we need to give it some axis titles. All right. So if we focus here, we'll name our dependent axis. Cutting that back. All right. So over here, this is representing our growth. Okay. Which is kind of general to begin with, but that's okay. And our growth was taken in centimeters. Now we'll get into more detail when we get with your labs discussing margins of error, but for argument's sake, we're just learning how to make a graph right now. So our growth is in centimeters, and then our down, the independent variable here. Okay, we're looking at the time in days. And there we have our basic line graph, comparing that. Fair enough. So now we want to also insert a separate column graph with the mean, all right, including error bars. So we're just going to graph these two means right here. So easy enough. So again, we can highlight our two sets of data. Whoop. Sorry. We're going to drag it over. So we highlight our two sets of data. We can insert our column. All right. We're just going to whoop. Just want to move it over. So it's not with our other graph. There we go. So again, we don't need a chart title, so we get rid of that. Okay. We can label these axes. All right. So one thing we can do here is if we go up to select data over here, all right, we get different commands. We can edit our axis label down below, and we can, now we get growth of plant 1 and growth of plant 2. All right, that was going up to select data and looking at the axis labels and just highlighting what we had before. All right, so now we want to look to include error bars. Okay, so let's just get out of this. We don't need that anymore. Whoop. Let's undo and get that back. Okay, so I just had to get that back. All right, so now we want to add some error bars. So we're going to go to the plus here, and we want to add some error bars. Okay, but we're going to do more options. So we go to more options. Here's our options over here. So we want custom error bars. All right, so we need to specify our values. We're going to use our standard deviations. So we specify value. And what we're going to do is we're going to go down to the standard deviation, highlight the two standard deviations. Let me go back. I forgot to. You want to delete the values in there. So we do for the negative, and we do the same two numbers for the positive. We hit OK. So here are two error bars. All right. Let me just make sure that went well. Okay. I'm just going to run through that one more time. So we do the positive value. We're going to highlight our standard deviation. I don't think it went correct last time. And we do both. We highlight both standard deviations, and then we highlight, for both plants 1 and plant 2, the same ones for the negative. And then we hit OK. And there are our error bars successful. And again, you would go back and graph or add the axis titles like we did before, growth, but this is just representing the means. All right, so you might want to change this. So hopefully this tutorial is helpful. There's going to be another one that I'm going to do that's going to show you about scatter plot and adding line of best fit. Thanks, and I hope this was a good help for you.